Well, here's a little project or invention I've been working on for a couple weeks. Um, as some of you might know, I'm an automotive mechanic, or at least I pretend to be one during the day. And quite often when I'm working on a car, I'm trying to find a noise, like a clunk or something, and it's over bumps. And I can hear it when I'm driving on the road, but then you bring the car into the shop and you put it up in the air, and you can't find anything. And you say, oh, it's going to have to get worse, you'll have to come back later. Blah, blah, blah. I don't know what it is basically what you're trying to say. So, I've seen these shaker rigs that they have for racing applications and testing race cars, and they're pretty advanced hydraulic systems. But I was thinking I could build myself a real simple one that I could just throw under a car on a ramp type hoist where you would drive onto, and it would simulate the car going over bumps. So this is kind of prototype number one here, and I'll just plug it in. So what we've got here is a gear reduction motor, and because I already had this motor, I had to reduce it a little bit further. Ideally I would get one that turns even slower than this, but what I've done is I've just made this hinged plate, and it runs off a cam that I built. And I kind of played around with the size of the cam. It's given me about a 1-inch bump. So the idea is going to be that I'm going to drive the car up onto this plate, and I'm going to be able to just plug this in, and I'm going to be able to see the suspension moving on the car. It's a bit of a shot in the dark as far as how much load this is going to be able to carry and how much force it's going to take to lift the car on a cam. So I just kind of went for it. I figured, average car, let's even just say 4,000 pounds, perhaps 1,000 pound on one wheel. Then this is a lever, so you're kind of cutting that force in half. So that's, because it's at 50% on the lever, you're maybe 500 pounds. Then you're taking into account the fact that it's bouncing, so as it hits down, it's going to increase that weight, right? It's kind of like pushing down on the plate. So basically, I was thinking about 1,000 pounds, so I kind of beefed everything up as far as I could tell to handle 1,000 pounds, and with the car on it, it seems to take it. I've only done my van so far. I haven't put a heavy truck, but it's not laboring. I mean, obviously I only weigh maybe between 1 and 200 pounds, depending on how much I've been eating, but nothing else, I might be able to turn it into some kind of 50s-esque exercise machine. So those of you that do work on cars, you'll probably see why this is such a useful tool. To get a car's suspension to move like this on the hoist is pretty tough otherwise. I can put my hand up on the coils here. I can feel for any clunking noises. Here I'm underneath the car. You can see how the plate's jarring the suspension here. I'm able to hold on to things like sway bar links. I can look at the control arm bushings here, see if they're moving, if there's anything odd going on there. Also, if there was a clunk on the strut or something like the front strut mount, I could see that. Anyways, it's an interesting way to try and simulate a bump on the road that you can't duplicate on the hoist. And this is a major problem as far as working on cars. Anyone that works on cars will know that lots of things aren't that easy to find if you can't clearly see something loose on the hoist. And this gives you a bit of an extra tool to work with. Anyways, still a prototype, still working on it. I'm sure you guys might have some thoughts or comments or ideas as far as different things I could do to improve on it, but I'm going to start using it here and see what I can do with it. Thanks for watching.